Hi, welcome to How to Repair. As you all know, I normally fix domestic appliances and I'm a firm advocate of the right to repair, saving these appliances from going on the landfill or any other electrical items. And last week I nearly became part of the problem myself. I've actually got a cordless drill that I've owned for 3 or 4 years. It's been a great drill, fits nicely in my hand, easy to work with, but I burnt the drill out. The motor failed on this drill. Now, I was about just to go out and buy a new drill because at £60–70 they're not that expensive to replace. But I thought, how can I preach one thing and do another? Because there's 2 good batteries with this drill and a good charger, and those batteries are not going to fit into the newer models of drill that I was thinking of buying. So all this would become waste. I might be able to salvage the cells out of those batteries to use in other drills, which I'll be doing other videos on. But I decided to do some research. Now, when looking at the actual model and make, Metabo, and the model of the drill, I was unable to find a motor. So after stripping it down, there were some identification marks on the motor, which I was then able to understand which motor fitted in this drill. And I was pleasantly surprised that I was able to get the motor for £8 off Amazon. Simple, here in a few days. So not only am I going to show you how to test the batteries, diagnose the problems on this drill, but also how to replace the motor as well. I hope you enjoy the video. Okay, I thought I'd quickly run through some of the tools that you need and also why you need them. Now, firstly, you're going to need a multimeter that reads DC voltage and also continuity. You might need ohms with further videos that I'll be doing at a later stage, but I'm keeping this video very basic and in layman terms so everyone understands. It's also useful to have some crocodile clips that attach to your meter. This way, when you're actually testing wiring inside the actual drill, you're able to clamp the actual connection onto the actual wire, and this keeps your hands free while taking readings. Very useful to have. You'll also notice I've made some basically little jump wires, and they have got black, red, positive, negative, and I've put some spade terminals on each end. And this is because the probes on a lot of multimeters will not get into some of the cavities on the actual batteries to be able to take voltage readings, and also it may be tricky inside the drill as well. Pin nose pliers, very useful. Normal screwdriver and Phillips screwdriver will be needed. Now, with a lot of manufacturers today, they put safety screws into the actual drills to stop people taking them apart. And there are 2 types of Torx that are in use. You've got normal Torx screwdriver, and this is a 10, and this is adequate for this drill. But on some drills, they use Torx safety screws, and that means that the Torx safety screw has a very small pin in the middle, basically stopping you using the normal Torx for that. You will need Torx safety screws to undo some of the battery packs and also undo some of the drills. And also another tool that I have, which is really useful, is basically a set of miniature jump leads. And this is going to allow me to connect the battery up when the drill is open to test certain components with voltage. But you'll see more about that later in the video. Okay, the first thing we're going to deal with is the battery, how to check it, and also have an understanding of how the charger initiates a charge into the battery and the requirements the battery charger needs to see to be able to charge the battery correctly. Now, my old science teacher always used to say, when you've got something complicated to explain, keep it simple but keep it accurate.
You're goddamn right.
And I must thank Rob Burris for actually teaching me that when I was a youngster. There are 3 cells in this battery, and these cells are connected in series. Now, if you imagine you had building blocks and you stack them on top of each other, all 3 batteries would be stacked on top of each other, meaning the bottom battery will be connected to the next battery, positive to negative, and then the next battery will be positive to negative. And the actual voltage will be read at the battery from the bottom and the top, giving us 10.8 volts, which is the nominal charge in these batteries. Now, because the cells are 2000 milliamp hour, that gives us a 2 amp hour battery at 10.8 volts. Fully charged, we would expect to see this battery somewhere in the region of about 12.4 volts. Now, When a battery has got larger capacity, you have to think of it as the voltage that is required. So we have 3 batteries, but then the foundations would be wider, meaning that you would have batteries in parallel. And I've got a good example of this because I've got some Bosch batteries I've got to repair here. Although these batteries are 18 volts, this is a 2 amp hour battery and this one is a 4 amp hour battery. Now this has got 5 cells connected in series, achieving the 18 volts that's required to operate the drill. This battery has got 10 cells in it, 2 strings of 5 cells in series connected in parallel, meaning it has got the same voltage as this battery, but twice the power. So I'll put up on the screen to explain to you. Series is when you're joining them one by one on top of each other, increasing the voltage. In parallel, you are increasing the foundation or increasing the ampage. And you can have multiple different configurations within a battery bank of the way the designer made it for that drill. And it's very important to understand the construction, because unless certain voltages are reached or understood by the charger, the charge would not be initiated. Now, this battery, for example, has got all the cells are dead, meaning it's got nearly 0 voltage in it. But this battery, surprisingly enough, has got 8 cells in good condition, but 2 cells which are in poor condition or not working at all. And this should be reading 18 volt. And if I turn my meter on here and go across the positive and negative, I think I'm the right way round there. No, I'm not. Wrong way. Going across the 2, we only have 15 volts. This means that the Bosch charger would not initiate the charge into this battery because it understands that the cells are damaged or the configuration is not correct for the charger to safely put a charge into these batteries. As you've all seen on the news, lithium-ion fires and everything else. So the battery management systems are very important when it comes to initiating a charge into a cell. Because if it did try to put a charge in at 18 volts to this battery bank that is only capable of 15 volts, the cells would get hot and possibly cause a fire. That all said, let's look at the voltage on our battery. Now I'm going to take the one off here and swap them over because this now is a fully charged battery. And as I said, we have our positive and negative, but I'm unable to get my probes in there to take a reading. So I have my 2 jump leads which I've created, which I will just put into the slot here. And going across the negative to the positive, I have 12.44 volts. This means that this battery is good. Now, once it has had power drawn off it, the voltage will drop. And once it drops down to about 11 volts and you put it into the charger then would initiate a charge, taking it back up to the optimum level for this battery. Now, going a little bit more technical, but I'm not going to go into heavy depth here. Each of the cells in here are approximately 3.6, 3.7, and they're 2000 milliamp hours. This means that if one cell was damaged and not working correctly, we would only have a voltage of approximately 7, maybe 8 volts, because one of the cells was not working correctly. Therefore, when I put it into this charger, the light may just stay green and not be flashing because no charge is going into the battery, because the BMS battery management system has detected a fault on the system. I hope I've explained that correctly for you. Now let's start taking the drill apart to have a look at the problem. Okay, we've already discussed the different screws on drills and everything else. You want to take a closer look around at where all the screw configurations are, but also sometimes understand that there may be clips that can be holding the 2 halves of the body together. And this belt clip here at the back would also stop the actual casing coming apart. So we need to actually press down the button inside and drag out the clip. That's the first thing we need to do. Now we need to remove all the screws. But quickly, before I start, I just want you to get an understanding of what some insights are. Plugging a battery into this drill, we can press the trigger and the light comes on. This is a good sign that the trigger mechanism is working correctly, but I'll also show you how to test that when we got it apart. Sometimes you may even get what you call plastic inserts covering the screw holes, and in that case you will sometimes have to use a sharp object just to prise these out to expose the screws. But we'll just quickly undo these. Now do note when taking them out to make sure if any are any longer than the others to take note of where they came from. All these screws were the same length. Now we can try and carefully prise the two halves of the plastic casing apart. This exposes the motor, the trigger unit, and the battery housing itself. We have the connection point for the battery, which is 12 volts. One's positive, one's negative. This sends the power to the switch. The switch then sends the power to the motor. Now, the switch is a variable switch, meaning the more you press the trigger, the higher the RPM will be on the motor. You also have a different torque setting with the motor on the top. And this just gives the motor either a higher RPM with less torque or a lower RPM with more torque. Now, this switch actually reverses the polarity when you press the button for the directions. So in one direction, the positive will be on this side and the negative on this side. But when the switch is pushed down, the positive and negative will be reversed. In other words, changing the polarity. Now, what I'm going to do is insert the battery, carefully putting it down here. And by the way, you will notice on top of the motor here, there's lots of fragments of steel, which is a good indication that the motor has burnt out internally. Now, what I'm going to do now is firstly just press the trigger. The light comes on, but there is no motor action at all. But we want to check that the trigger is sending voltage through to the motor. And the easiest way of doing this, if I use these small jump leads, because they're going to be a lot easier than my larger ones, and I'll connect the positive side up to the positive side on the meter, the negative to the negative side on the meter. I'll make sure that you can see that there. And it doesn't really matter which way I put these on because the switch is going to reverse the polarity. But if I put the negative and the positive on the motor there, and now I press the trigger, we have the positive going through on this side at the moment. And if I try to move my hand out of the way, you can see that the red is where the positive's going. Now, if I throw this switch over, it's reversed the polarity. So now the positive will come through on this side. And the meter shows this by an actual minus symbol, meaning that the polarity is reversed. And we have no motor action here at all. If I grab the new motor and I take my leads off and connect it to the motor, making sure I insulate them well. And let me just put this down here out of the way. And I press the trigger. The motor is rotating in a clockwise direction. If I throw that switch over, the motor is working in the anti-clockwise rotation. And that is all done by reversing the polarity. Now all I need to do is disconnect the motor from the wiring. And I was hoping it was going to be spade terminals, but they are soldered on, so I'm going to have to unsolder them and then remove the motor from the gearbox unit and then insert the new motor. But I'll also explain to you how I sourced this motor as well, because that's the most important part of being able to repair this drill. Now, as you will notice, on this side of the motor there is no identification marks whatsoever. And sometimes when you actually take a drill apart, you may take it apart and not be able to see the numbers. So the easiest way of doing it is insert the case back on, rotate it over, and then dismantle it from the other side. And if I carefully try and prise this apart, there will be some wires attached to this because of the light. So if I lean that over, now on the other side you can see there is a number, and there's a load of fragments on here, and that number corresponds with the new motor that I did a search on. And this is how I was able to identify and look on Amazon and other shopping channels to make sure you were able to get the correct motor. And the number I used was 317-005-100. And that led me to be able to obtain this motor. And I was able to get this for as little as £8, which is well worth repairing the actual drill. Okay, now we're going to remove the motor, and I have to desolder the wires on the back. So I'm just carefully prising this up slightly. I've got some desolder wire here which will suck off the old solder. But first I need to heat this up. Might take a few seconds just to melt the solder. And as you can see, the wire has fallen away. And now I'll do the other side. It's a little bit tricky trying to film this for you and do it in an angle which is not really natural to me. Just melt the solder and then pull the wire away. I'll clean them up in a minute. And now I can carefully remove the motor from the gearbox. And there is the old motor. Right, we'll insert the new motor, but I'm just going to put a small touch of grease on these cogs just to prolong the life. You only need to use a very small amount. You don't want to put too much on there. And now we can drop the motor in, making sure it lines up on the cogs inside the gearbox. And there she goes. Now we can drop that down. I'm going to clean up the two wires and then resolder these on. And I might need to put a little bit of sleeving on this wire, because the wire itself does look slightly damaged. Okay, I've got a piece of heat shrink here, but I'm just going to cut off this bit of damaged wire. Then I'm going to cut the heat shrink to the length that I require. It is quite fidgety trying to do this and make sure that you can see it on the camera. Now carefully just put this wire I might just need to melt this a little. It looks a little bit on the thick side. And there she goes. That wire is through. I'll do the same on the other side, and then we'll put some flux and some solder on. And if I bring this up to the camera for you, you can see there's a hole on the motor tag. And I'm just going to make sure the wire goes through that hole. Okay, using a little bit of flux and a very small screwdriver. That will melt onto the actual copper in a second. You don't want too much on there. Make sure that you have a very good connection. And I'll just try and move my hand out of the way. And that looks absolutely perfect. And make sure I tuck the wires in now to make sure they don't catch on anything when I actually put the casing together. Okay, once you've actually got it all together and ready to reassemble, it is worth making sure that you put your finger on top of the motor and top of the gearbox to make sure there's no movement, because what we want to check here, that the cogs is lining up correctly on the gearbox and making sure that everything works on the drill before reassembling. And it's just checking the alignment basically. So pressing the trigger down, we have one rotation. Pressing the trigger up, we have the other rotation. And then of course you've got the gearbox for engaging the different speeds, but really that is quite difficult to hold in place while holding the motor. But as long as this is all lining up perfectly, you are now ready to reassemble. Okay, make sure all your wiring doesn't get caught when you actually put the casing on. Just carefully drop it down. Push it into place. And there we go. I've got a new drill and it saved me a few quid, but more importantly, it stopped this going into the landfill. Thank you very much indeed for watching the video. Do remember, any parts that I used or any tools, everything will be in the description on this video. And I'll put a page together on the website with some useful links as well. Please remember to give the video a thumbs up, subscribe to the channel if you wish, and if we really helped you, you can always click on the Buy Paula Beer page. Thank you very much indeed for watching.